Today we'll be taking a look at odd even linked list on LeetCode. It is problem number 328. So let's take a look. Given the head of a singly linked list, group all the nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. The first node is considered odd, and the second node is even, and so on. So this is important because it's the ranking of the list that's odd and even, not so much the values at that node. So another thing that we should note here, it should be solved in O of 1 space and O of n time. So let's take a look at an example here. In example 1, we have 1, 2, 3, 4, 5. 1, 3, and 5 are odd indices, so they should be grouped at first. And 2 and 4 are the even indices, so they should be grouped last. So over here, it's just by the example, the odd indices are odd, and the even indices are even, but really we do not care about the value at that node. It's just about whether it's odd or even in its ranking. So let's try to visualize this to get a better idea of what our solution will look like. So if we take a look at here at the linked list from example 1, we see that the odd indices are colored in blue and the even indices are colored in orange. And what our solution will pretty much look like, if we imagine it, is 1 will point to 3, and then 3 will point to 5. And then we can imagine 2 pointing to 4, and now we have all our odd indices grouped in one list and all our even indices grouped in one list. And then what we want to do is pretty much connect this last indice from the odd to the even, and now this little, I guess, circle-ish shape we have here would be what our final linked list looks like. So now let's take what we just described and break that down by step. So we described grouping all the odd indices in one list and all the even indices in one list. And then finally, we're going to attach the two lists together. If we want to imagine us grouping the indices together, we should have a head for our odd indices. So let's make a new head. And this is going to be odd. And now let's just copy this. And now this is going to be our even head. And then let's give this a separate color. So now these are the heads of the two new lists we are going to create. We are going to create this in O of 1 additional space because we're just going to attach the elements from this list onto here. And that way we're not using more space by creating new nodes. So what we would also probably need is we want to imagine we have two other pointers. And these pointers are going to be references to the last node in each of these lists. So we can imagine them as odd tail pointer and the even tail pointer. Right now we have a pointer to even, and let's call that even tail. And we have a pointer to odd, and then we just have our regular pointer here that points to the node. Let's just call it head. And then we're going to have another variable. Let's call it odd. And if it's odd, we know we are looking at an odd indices, so we should add to the odd tail. If it's not odd, then by default we know it's even, and we are looking at an even indice, and we should add it to the even tail. So now we are at the first indices. Odd is true. That means we should be adding this head node here to our odd linked list. So we're going to say odd tail because that's the pointer to the last node in the list. The next value it should be is going to be head because right now head is at an odd indices. And I'm going to be drawing new nodes here, but let's remember these aren't actually new nodes, and this is just a visualization of it. Once we do that, we also move over our odd pointer. We move over our head pointer. Okay, so now we are at our second indice here. We know we should be looking here. That means we should be creating a new reference, and it's going to point here. We move over the even tail here, and we move over the head. And now we can start to see a pattern forming. And once we get back to head at 3, and we're just going to repeat what we did before. This is going to be 3. We move over our pointer here. We move over our pointer at the original linked list. And then same idea here. This is going to point to the next even index, which is 4. We now move over our even tail to be at the last node of this even linked list again. We move over our head in the original linked list, and we draw the final node, 5. We move over our odd tail. Our head pointer is now outside of the linked list, meaning it is null. The list is empty. Okay, great. We have taken our linked list and we have broken it down into two lists, one of just odd indices and one of just even indices. And now we just want to combine the two together. One thing we want to do here, and it might not be obvious from the visualization, but just the way the list is set up, we can see here that this is 4, right? And 4 in our original linked list points to 5. So we want to make sure for our even tail that we make sure that the next pointer points to null. And that way we won't end up in a situation which is a cycle. Because if we imagine attaching this node to here, right? And if this node is still pointing to the 5 up ahead, it's going to traverse down this list to the 5. And then once it gets to 4, it's not going to go to null, except it's going to go back to 5. So that's just a caveat we have to add into our code, but I wanted to point that out here. Now what we want to do is we want to take the 5 here, and we want to point it not to the even head, because that's just an empty reference head. We want to point it to the next node in even. So what we really want to do is we want to take odd tail, and we want to point this to even dot next, because right now even is the head node, dot next would be the first node of even indices, and once we do that, this will be gone. Then it's going to be like this here. And then finally we want to return not this odd head node, which is just a reference node. We want to return the node after that. So we simply return odd dot next, and that will be our full solution. So now let's jump back to the code. So now that we jump back to the code, let's start coding everything that we visualized. So we know that first we need to create 2 reference nodes to the odd and even linked lists, and we need to have reference nodes for their tails as well too. So let's do that. Odd list node, and let's call it odd head equals new list node, and then let's call it odd tail, and this is going to point to the last node in odd head, which when we're starting out is going to be odd head itself. Now let's do the same for even head. Make a new reference node and point even tail to the last node in our even linked list. Then let's set up our boolean variable odd equals true. Now this is going to be toggled on and off in each indices. For odd indices it's going to be on, so we know we should be pointing at the odd head. For even indices it's going to be off, meaning we're going to be pointing at the even head. And then let's iterate over our list node head while it does not equal null. So while there's still information here, let's iterate over it. And then we're going to say if odd, meaning if we're at an odd index, what we want to do is odd tail dot next equals head. So we're at the last node in the odd linked list. We want the next node to be the current node we're looking at. And then we want to move our odd tail a position forward like we did in our visualization example to the now last node in our odd linked list, which in this case here, if we're still following example 1, should be now 1 instead of the reference node head. Else we know we're going to be at an even index by default, so we know this should go to the even linked list. So the same logic here except for even. So now this is going to add the index to its appropriate odd or even linked list. And once we come outside of it, we actually want to do is head equals head dot next. So move our original linked list forward. And then finally, we want to set our odd variable to be not odd. And this is just going to toggle it on and off. So after an odd index, it's going to be off, indicating it's an even index. And when it's an even index false, it's going to be then toggled on. So it's going to be true, meaning next time we're going to be at an odd index again. And now this is going to create both of our linked lists. And once we step outside of here, we want to make sure we add that part that we mentioned in the visualization where odd.next equals null, so we don't have any cycles in our linked list. And then we want to point our odd tail, right? So the last node in our odd linked list to the first node in our even linked list, which is not going to be the reference node, which is going to be the node after that. That's why we use .next. And now, just like we mentioned in our visualization, we want to return the whole linked list now, except for the first node, because that was just a reference node to start building our odd linked list. So we're going to do odd head dot next, and this is going to give us the next value, or the first value, we can think of it, in our odd linked list. So let's try running this. And voila, there we go. It has passed all the tests and it's 100% faster than all Java solutions. So hopefully you guys enjoyed that and found it educational. If you did, please consider liking and subscribing, and see you guys next time.